Good morning, children. Today in this class we are going to see about carbon and its compounds. Okay, carbon is a very important element in our day-to-day life, and it has a vital role in our day-to-day life. And now we are going to see about what is carbon and what are its compounds. In this lesson, we are going to see the special features of carbon, isomerism and allotropic forms of carbon, differentiate between the properties of graphite and diamond, recognize the various inorganic carbon compounds with their uses, common properties of carbon compounds, codes of various plastics, and effects of plastics on human life and environment, knows the legal measures to prevent plastic pollution. So let us have an introduction about carbon. Carbon is one of the important non-metallic elements. So first we have to know is carbon is a non-metallic element. It is not a metal, it is a non-metal. Antoine Lavoisier named carbon from the Latin word carbo meaning coal. What is the meaning of carbon means coal? Coal is nothing but carbon. This is because carbon is the main constituent of coal. Coal is a fossil fuel developed from prolonged decomposition of buried plants and animals. What is a coal? The prolonged decomposed bodies of plants and animals. After some millions of years it becomes carbon. The earth crust contains only 0.03 percentage of carbon, that 320 parts of per million by weight in the form of minerals like carbonates, coal, petroleum, and the atmospheric has only 0.03 percentage of carbon dioxide. Even though available in smaller amount in nature, carbon compounds have an immense importance in everyday life. It is in traces. Carbon is found only in traces in our environment. Even though it is found in very traces of element, it is very important in our day-to-day life. It plays a vital role in our day-to-day life. Carbon is present in our muscles, bones, organs, blood, and other components of living matter. A large number of things which we use in our daily life are made up of carbon compounds. So without carbon, there is no possibility for the existence of plants and animals, including human. Thus, carbon chemistry is also called as living chemistry. The study of chemistry, the study of carbon in chemistry is called as carbon chemistry, and it is also called as living chemistry. In this lesson, we will study about the special features of carbon, its properties, and also about plastics, which are the catenated long chain compounds. Discovery of carbon, milestones. Carbon has been known since ancient times in the form of soot, charcoal, graphite, and diamonds. Ancient cultures did not realize, of course, these substances were different forms of the same element. In 1772, a French scientist, Antoine Lavoisier, pooled resources with other chemists to buy a diamond, which they placed in the closed glass jar. They focused the sun's rays on the diamond with remarkable giant magnifying glass and saw the diamond burn and disappear. Lavoisier noted that overall weight of the charge was unchanged and that when it burned, diamond had combined with oxygen to form carbon dioxide. He concluded that diamond and charcoal were made up of the same element, carbon. Okay, so Antoine Lavoisier found carbon by having an experiment, and he had found that diamond and charcoal were made of the same element, carbon. Diamond, after millions of years of decomposition under the soil, it has become, which has become the carbon, which is in the dead decomposed plants and animals, has become diamond after millions of years. Okay, so he has concluded that charcoal is nothing but, after millions of years, it will become a diamond, and the main part in the charcoal as well as in the diamond is nothing but carbon. In 1979, Swedish scientist Carl Scheele showed that the graphite also burned to form carbon dioxide. English chemist Simpson Tennant established that diamond is pure carbon and not a compound of carbon and burned to form only carbon dioxide. Tennant also proved that when equal weights of charcoal and diamonds were burned, they produced the same amount of carbon dioxide. In 1855, English chemist Benjamin Brodie produced pure graphite from carbon, proving graphite is a form of carbon. So, the scientists are undergoing tests and proving that graphite, diamond, charcoal, all these are having a main constituent which is called as carbon. Okay, so same here, carbon, Robert Curl, Harry, Croto, Richard Smalley, everyone are having some discoveries regarding carbon. So now we are going to see about the compounds of carbon. Carbon is found both in free state as well as in combined state in nature. In the prehistoric period of ancients used to manufacture charcoal by burning organic materials. They used to obtain carbon compounds both from living things as well as non-living things. Thus, in the early 19th century, Berzelius classified carbon compounds based on the source as follows. Organic carbon compounds. These are the compounds of carbon obtained from living organisms such as plants and animals exempt, ethanol, cellulose and starch. Inorganic carbon compounds. There are two types of carbon compounds, one which are obtained in organic carbon compounds and another one is obtained in inorganic carbon compounds. Okay, what are the organic carbon compounds? They are obtained from ethanol, cellulose and starch. The inorganic carbon compounds are obtained from calcium carbonate, carbon monoxide and carbon dioxide. Organic compounds of carbon. There are millions of organic compounds available in nature and also synthesized manually. Organic carbon compounds contain carbon connected with other elements like hydrogen, oxygen, nitrogen, sulfur. Thus, depending upon the nature of the elements and the way in which they are connected to the carbon, and there are various classes of organic compounds such as hydrocarbons, alcohols, aldehydes, ketones, carboxylic acid, amino acids, etc. You will study about organic compounds in your higher classes. Organic chemistry completely deals with carbon and hydrogen. Inorganic carbon compounds, as compared to organic compounds, the number of inorganic compounds are limited, okay, where organic carbon compounds are more in number, but inorganic carbon compounds are lesser in number. Among them, oxides, carbides, sulfates, cyanides, carbonates, bicarbonates are the major classes of inorganic carbon compounds. Formation, properties and use of some of the compounds are given below. Okay, now we are going to see about special features of carbon. The number of carbon compounds known at present is more than 5 million. Many newer compounds are being isolated or prepared every day, even though the abundance of carbon is less, the number of carbon compounds alone is more than the number of compounds of the all elements taken together. Why it is that is property is seen in carbon and no other elements? Because carbon has the following unique compounds. See here, there is a tabular column and they have given some inorganic carbon compounds. Carbon monoxide, carbon dioxide, calcium carbonate, calcium disulfate, calcium carbonate, etc. They occur in nature. So the formation, properties and uses of these compounds are given here. Okay, so now we are going to see about catenation. What is catenation? Catenation is the binding of an element to itself with other elements through covalent bond. Catenation, binding of elements. A is being binded with B through a covalent bond. This is called as catenation. Carbon is the most common element which undergo catenation and forms long chain compounds. Carbon atoms link repeatedly to itself through covalent bond to form linear chain. See here, the carbon bonds are linked together with the covalent bond. They are called as branched chain. See here, if there are branches, and it is called as branched chain, and if they are linear in structure, they are called linear chain. See here, if they are connected with the ring, it is called as ring chain. This is called as catenation and they are linked with the covalent bond. Okay. So, this property of carbon itself is the reason for the presence of large number of organic compounds. So, organic chemistry essentially deals with the catenated carbon compounds. So, next for example, starch and cellulose contain chains of hundreds of carbon atoms. Even plastics we use in our day-to-day life are macromolecules of catenated carbon compounds. Catenated carbon compounds means carbon-carbon, the link between carbon-carbon covalent bond, and they have a big ring structure, and if it is a macromolecule, the plastics are made up of these compounds. Okay, so tetravalency. Another versatile nature of carbon is its tetravalency. If they are having only one valency, it is called monovalent, divalent, trivalent, and the fourth one is tetravalent. That is the property, main property of a carbon compound, because it is tetravalent in nature. The shell electronic configuration of carbon is 2,4. It has 4 electrons in its outermost orbit according to octet rule. Carbon requires 4 electrons to the nearest noble gas electronic configuration. So, carbon has the tendency to share its 4 electrons with other atoms to complete its octet. This is called as tetravalency. Thus, carbon can form 4 covalent bonds with other animals. For example, in methane, carbon atom share its 4 valence electrons with 4 hydrogen atom to form 4 hydrogen bonds and hence tetravalent. See here, The valency of carbon is 4 and here hydrogen, and they are formed. So, see here, this is the tetravalent nature of carbon. So far we have seen about carbon and its compounds, and now we are going to see, we have seen about the tetravalency of carbon, and next we are going to see about the multiple bond and isomerism of carbon. Okay, so stay here, stay safe, and let me continue and let me see in the next session. Thank you.